This video gonna prove something that looks very similar to the last video. This time we're starting off with H as a subgroup of G. And then we define this new set that depends upon or is a function of the fact that H is a subgroup. C of H is defined to be all the elements in G that commute with every element in H. So if H is in H, that implies that XH equals HX if X is in this set. And this is for all H. Every element that's in capital H, for X to be in this set, X has to commute with each and every element in H. And if that's true, then this X element belongs to C of H. And we want to show that C of H is a subgroup. So how about we get right into the proof? So to get in, you have to be elements of G. And this is the subset of G. It's only some, maybe even all elements of G. But it's not bigger than G. So let X and Y be elements of C of H. Now we want to show closure. We want to look at XY. Okay. So here, let H be any element of H. So XY times H. This is the same as X times YH. But Y commutes with every element in H. So it's X times HX. Associative law, we get HX times Y, I meant to say. Guess I meant to say that twice, I'm sorry. But X is in this special set, C of H. So X commutes with every element of H. So HX times X times Y. Okay, one last line and we have it. I hope. This is H times XY. And this is for all H and H. This is equal to that for all H in capital H. That implies that XY is an element of C of H. So we have closure. Now we have to show inverses. Let X be in C of H. Okay? Well, that implies that XH equals HX for all H and H. Okay, so we have this. So I'm going to multiply on both sides of this equation by X inverse, X inverse, X inverse, X inverse. Plays associative game. I'll group those two, then I'll group the last two, I'll group the first two, I'll group the last two. That's E. So we have E times this. That's E. So we have X inverse H times E. Well, E times this is just this, and that times E is just that. And remember, this is for all H and H. Ooh, X inverse commutes with all elements of the subgroup H. This implies that X inverse is a member or an element of C of H, which implies C of H has inverses. Therefore, the fact that it's closed, C of H, and the fact that it has inverses, we have that C of H is a subgroup of the group G. If you like watching videos like this, please subscribe to my channel. I assure you, you will continue to enjoy watching these type of videos. If this is what you're into, it's a no-brainer in my opinion. Please subscribe. Click the like button for this video. Please leave a comment. Thanks for watching to the end of the video. See you guys in the next video. Watch and learn.